Dr. Shyam Sundar, Professor Sina, Jagdish, and Professor Jayaraman, Umesh Chandra, and the keynote address which they made today's Vartika Shukla and the advisor PMO Tarun Kapoor, which they spoke about the today's morning inaugural section. Sunil Kumar, Joint Secretary MOPNG. I'll be just since the time is essence of the today's session, I'll be short and make apt in my time. Let me go through this presentation, run through. Maybe some of the slides I may go a little faster. I'll be talking about the asset integrity, management system and retrofitting of refinery equipments. So the BPCL group of refineries, we have 3 refineries, Mumbai Refinery, Kochi and Bina. Basically we process 12 million in Mumbai, 15 in Kochi, and Bina is 7.8. So we have processing various type of crudes. There are 100 type of crudes in Mumbai alone, and in Kochi 103 various type of crudes. As he rightly said, the asset which undergo the various type of the chemical processes. So the need of an hour is to take the asset into integrity is very, very crucial. Now I think this is a very simple, the typical process of refining, where we get the crude and goes to the column where the distillation takes place. Various refining process happens. The various streams come out of the column, and there are downstream processes. I will not go in much. I think many people are, the oil industries and many power sectors are already aware of it. Now, this is our Mumbai refinery in 1955. If you look at this picture, it is only, you can see very few units. We were at 2 million when we constructed. The refinery has grown up to 12 million metric ton now. That if you see the asset, this particular one, the old unit still we are able to maintain it all with the asset, the integrity which is still in the process. This is the latest photograph, which is if you see the many units, the greenery is still maintained. Now the asset integrity management, I will be talking why the asset management system is essential. What is the reliability of an asset, then improve the safety, then enhance the operational availabilities, the optimization of maintenance cost, reduce turnaround efforts. So these are the main asset integrity management system which we follow. Basically they are typical which we follow in the, where are the static assets and the rotating assets. Like the static, we based on the risk-based condition monitoring, the inspection systems, and the thickness monitoring, and the online measurements. In terms of rotary, the reliability center maintenance, which we are in currently, it is in the process. The failure mode efforts, effects analysis, the strategy management, the life cycle cost analysis, which is being done in the rotating assets. Now this is static asset. I think the many speakers is going to talk over a couple of sessions now. So I will not talk much on the static asset. I will just go the rotary asset, which is very important and pertinent if you look at as a refining process. The most of the equipment troubles which we come across, the maximum of the rotating equipment, if any of the refining process. If you look at the rotary asset, first the data gathering is like we get the, as rightly said, the P&D is very, very important. When you look at the technical data where you don't have a data, then we will not able to do the analysis. When the second analysis, when we do this, the RCM, reliability center maintenance, where the failure modes and the failure effects which are analyzed. There is a There's an ASM, they validate the recommendations. Based on the recommendations, you implement it. So this is a typical process. Wherever implementation is still there is a problem, then you go back to during the periodic evaluation, you go back to the again the managing, the again you redo the process and get the desired result. These are the dashboard which is being followed in Mumbai Refinery. The dashboards which we have the online ODR monitoring, where we get the data. The operator goes and take the data of the rotating equipment. It comes in the central dashboard. From the dashboard, you know the analysis goes, and from the analysis, the predictive work will be done upfront. So the warnings and the alerts will come, and depending upon alerts, because of this tool, it is really going to help the kind of pressure which every energy operator has. The asset need to perform 100% plus, and there is no possibility of stoppage of an equipment. This is another dashboard. Now, why we need to go for a retrofit of system? As rightly Dr. Manoj just told in in his presentation, if you look at the refinery assets are very old, and at times we need to go for an upgrade. At times we need to go for an reassessing that asset, and we need to get to a desired result. The performance is very important, so that your refinery is uninterruptedly is operating. So if you see that our refinery capacity was 2, we had gone ahead to 12 million is on nameplate. And the quality products, again there is a challenge due to the market demands. We need to keep up the assets and to meet that latest standards, the statutory compliances, and the energy management in the asset to perform efficiently, so that your bottom line of like your EBITDA gets more. And the fourth thing is the space. If you look at this IISCs, I think when I came, I was just to go Google it. It is 440 acres, whereas in our refinery is only 454 acres. So the kind of the space which is very optimal, and within that we need to perform and to get the more output. And of course the profitability, the assets are exposed 100% and still more. So the main driver is to have the continuous improvement, and the energy. If you don't address it on energy, and definitely that bottom line will go down. So I will just there are 4 case studies. I will just brush up faster due to the time. I will just go to the there is one modification which is done in the one of the unit, reformer unit. Basically the one of the column which is done is a divided wall column. Earlier we have a single column operation. If you look at this configuration, the original configuration is like on the left hand side, there are 2 splitters. It was worked in a series. The capacity enhancement could not be done. And if you see the post revamp configuration, that splitter has been done is parallel and pushing more feed, and this is achieved through the basically a divided wall column operation, which was one of the main aspect. If you look at the photograph, this is the photograph of this internal. This was done in situ, and with the remarkable time of if you see the benefit, the steam consumption has reduced to 248 tons, and even power savings are there, and in fact the fuel savings are around 9.8 tons, and the specific energy consumption is 0.75 MBN. If you see the energy index is 1.04 is a prominent figure, and that net realization is around 69 crores. This is another case study which normally we talk about the reliability when we operate an asset as the equipment is a pump which has a reliability issues going for over period of time. And basically, if you look at this design, there are multiple buffers, multiple margins. If you have the margins and you underutilize, also is a problem. That reliability issue was addressed, and this was done in a very short time, and this resulted in the operating of this equipment very steadily, because the reliability is also very very important, and there is an energy saving. If you look at this thing, that same typical units of unit 1 and unit 2, there are if you see that the payback period of 2.2 around 2.5 years. Yeah. So this is, I just want to take another 2 minutes of it. This is classically, if you look at any of the refineries, the reciprocating compressor is very very crucial. I think the rotary equipments are a little bit easier to handle, but recip are very very difficult to handle. This is one of the hydraulic very high pressure units. This unit we have done one of the modification, wherein the energy loss of this compressor due to the valve failure, which is tremendous. So I will just go to the next slide. If you see the old wall, if you see that, you can see the deposits and frequent failure, and the failure resulted in downtime and resulted in production loss, and again energy saving, because we need to have that. How to go about this? When we look at this, we have gone with the straight flow valves, and these straight flow valves will give more that downtime is very very less, and this gives, if you see the normal valves is 6 months time, but if you look at the straight flow valves, it is a 5-year interval. We need not to change the valves, and no machining on the valve components, no replacement for at least for 20 years. Of course, the energy reduction is around 4 to 6% straight away. So this gives more this thing, and in fact the pressure loss to the suction and discharge will be very very less. Okay. So I will skip. This is the calculation. If you look at it, this something around 86 lakhs per year. There is a tremendous saving on the energy. So this is the last case study. These are high energy efficiency blades which are in air fin coolers. If you look at the refinery process, many of the cooling process takes place either in the water cooler or in the air fin coolers. The air fin coolers are more in numbers, and this as traditionally we have the aluminum type of blades, and that has own difficulty, and the aerodynamic models are not there. So the quality over a period of time is improved, and it has a high durability and less cost. So this was one of the thing we have implemented. This saves around 4 crores in a year. So thank you so much.